Hello everyone, my name is Arthur Morris and welcome to Solving Inequalities and Using the Interval Notation. So in this particular lesson, we'll take a look at a new type of notation that we call interval notation, and we'll look at solving inequalities. Okay, so if I have the inequality x is greater than 3, in the past you may have used open circles and closed circles. However, with interval notation, we use parentheses and brackets. So if I do not have the or equal to bar under here, I use parentheses. So if I wanted to graph x is greater than 3, then I would come to my graph right here, place a parentheses, and since it's greater than, then I'll place a parentheses facing the right, and I would shade to the right going towards positive infinity. Now, interval notation can be written from the graph. So if I'm going from left to right, the first thing that I come to is the parentheses beside the positive 3. And I place a comma, and I continue on out to positive infinity. So the next thing that I would write would be my positive infinity, and the positive infinity or any infinity would always have the parentheses notation beside it. Okay, so let's look at this next one. We have x is greater than or equal to 3. If we do have the or equal to bar, we use the bracket to represent that. So again, I would go back to 3, and we're looking at greater than or equal to. So since I had the or equal to bar, I use a bracket here. And greater than would be to the right. That's why my bracket is facing the right. So interval notation starts with a bracket on positive 3 and goes all the way out to positive infinity. And again, infinity will always have a parentheses notation beside it. Okay, so what about x is less than 5? Well, I don't have the or equal to bar, so I would go to 5, positive 5 here, and place a parentheses, and since it's less than, then I'm going to face the left. Less than would be everything out here going on towards negative infinity. So again, when you write your interval notation, if you're looking at a graph, you're going from left to right. So the first thing that I run into coming from my left is negative infinity. So I would have parentheses, because parentheses is always by the infinities. And then it goes all the way over to positive 5. So I would put positive 5 here. And I had a parentheses by 5, so I would have a parentheses in my interval notation. Okay, so what about x is less than or equal to 5? Again, I have the or equal to bar. If I have the or equal to bar, then I use a bracket. So a bracket there, all the way out to negative infinity. When I'm writing in interval notation, I'm reading from left to right. So the first thing that I come to is my negative infinity. And going to the right, I stop at positive 5 with a bracket. So that would be my interval notation for that inequality. So that is interval notation. That's how you graph using the brackets and parentheses, and that's how you write your answers for inequalities in interval notation. Okay, now solving inequalities. Well, solving inequalities, we will use the same rules as what we use to solve equations. However, there is one catch to this. If we have to divide or multiply both sides of the inequality by a negative number, then we must reverse the inequality symbol. So again, the only rule that's a little bit different than solving equations will be most of the time it'll come towards your last step. If we have to divide or multiply both sides of the inequality by a negative number, then we must reverse the inequality symbol. So you may want to pause the video here and write down this information. Okay, let's look at a few examples here. So let's say we have negative 2x plus 12 is greater than or equal to 6. Well, we'll start off, we don't have fractions or parentheses, don't have like terms on one side or the other. All of my x's are already on the left-hand side. So the first thing that I need to do is to move that positive 12 by subtracting 12 from each side. So 6, take away 12, I spent more than I had, so that gives me negative 6. Then I would have to divide both sides by negative 2. Now, since I'm dividing both sides by a negative number, I have to remember to reverse my inequality symbol. Negative 6 divided by negative 2 is positive 3. So that would give me x is less than or equal to 3. So I will go to positive 3, and notice I have the or equal to bar. So if I wanted to graph this, we'll go to positive 3 and use a bracket. It's less than, so it's going to face the left. Shading all the way out to the left. So I would graph that. If I wanted to write an interval notation, remember you read from left to right. So the first thing that I run into is my negative infinity. And there's always a parentheses notation by negative or by my infinities. And then that goes all the way over to positive 3, where I had a bracket. So this would be my interval notation. Okay, so even on the problems where you don't have to graph, sometimes it's helpful to make a sketch of a graph to be able to write that interval notation. Okay, so let's look at this one. Using our equation solving rules, we want to clear the parentheses first. So we have 7 times x minus 3. It's less than 2 parentheses 4x minus 1. So we want to clear the parentheses first by using our distributive property. So that would give us 7x minus 21 is less than 8x minus 2. So after we clear the parentheses, I see that I have variables on both sides, so I'm going to move my variable terms. So I'll subtract 8x. So 7x minus 8x is negative 1x. Bring down the minus 21. It's less than negative 2. So now I need to move my constant terms or my numbers. So we want to add 21. So now I have negative 1x is less than 19. And the final step, since we want positive 1x, we would divide both sides by negative 1. So again, I divided both sides by a negative number. So again, I have to reverse my inequality symbol. 19 divided by negative 1 is negative 19. So I end up with x is greater than negative 19. So if I make a sketch of this graph, greater than negative 19, I do not have the or equal to, so it's going to be a parentheses. And since it's greater than, it's going to face the right. and it'll go all the way out to positive infinity. So my interval notation, reading from left to right, the first place that I start is negative 19 with the parentheses. Then I end up going all the way out to positive infinity. And infinities always have the parentheses notation beside. Okay, what if I have 1/5 plus 2/3 is greater than x over 15? So we've learned to clear out fractions, so that's what I'm going to do first. Find the least common denominator of my fractions and clear them out. So I have 5, 3, and 15. Since 5 and 3 will both go into 15, then my least common denominator for this one is 15. So I'm going to multiply both sides by 15, or 15 over 1. I will need to use my distributive property over here on my left-hand side since I had a plus in between those fractions. If I had a minus, I would still have to use the distributive property. 5 goes into 15 3 times, so I would have 3 times 1 there. 3 goes into 15 5 times, so I would have 5 times 2. On the right-hand side, 15 goes into 15 1 times, so I would have 1 times x. So let's multiply those out. 3 plus 10 is greater than 1x, understood 1. 3 plus 10 is 13. It's greater than x. Now, we don't leave our variable on the right-hand side. So if I'm looking at this, I see that my greater than is pointing towards 13 and my less than part is pointing towards x. That should still be the same when I reverse it around. So everything should reverse around. So the less than should still be pointed towards the x, and the greater than 13, x is less than 13. All right, so if I did a sketch of this on a number line, let's put a 0 here, and let's put 13 out here. If I want to sketch x is less than 13, I do not have the or equal to bar, so that means we should use the parentheses. Less than will go out to the left towards negative infinity. So to write my interval notation, the first thing that I run into out to my left is negative infinity. Moving on to the right, I stop at 13, positive 13. So that would be my interval notation for that one. Okay. All right, so what if I had 2, parentheses x minus 2 is greater than 2x minus 8? So we need to clear those parentheses first. 2 times x, 2 times negative 2, 2x minus 4 is greater than or equal to 2x minus 8. So after we clear the parentheses, what should we do? That's right. Let's get our variable terms together. Subtract 2x, subtract 2x, and 2x minus 2x cancels out on each side. So I'm left with negative 4 is greater than or equal to negative 8. So now, since my variables cancel out on each side, I have to ask myself, is this a true statement, what I have left? Is negative 4 greater than or equal to negative 8? Well, yes, negative 4 is bigger than negative 8. Remember, the farther to the left you go to the number line, the smaller the value. So this is a true statement. So that means that anything that I plug into for x will make a true statement. So that means this entire number line is my solution. Or from interval notation from left to right, negative infinity to positive infinity would be my solution. Now, if I would have had an untrue statement, then again, it would be no solution. All righty, let's look at one more example. All right, so x plus 4 over 5 minus 1 plus x over 8 is greater than or equal to negative 7/10. So again, the first thing that I want to do is to clear my denominators out, clear those fractions out. So 5, 8, and 10. 5 and 8 will not go into 10. Both of them won't go into 10. My next multiple of 10 is 20. 8 won't go into 20. My next multiple is 30. 8 still will not go into 30. My next multiple is 40. Both 5 and 8 will go into 40. So my least common denominator here is 40. So I will need to multiply both sides by 40 or 40 over 1. Using my distributive property here. So 5 will go into 40 8 times. So I would have 8 times x plus 4 minus 8 will go into 40 5 times. So I would have minus 5 times 1 plus x is greater than or equal to 10 will go into 40 4 times. So I would have negative 7 times 4. All right, so let's use our distributive property to clear the parentheses. 8 times x is 8x. 8 times 4 is 32. Now be careful here. We have to distribute this negative 5. So that's negative 5 times 1 is just still negative 5. Negative 5 times x is negative 5x. Negative 7 times 4, negative 28. So after clearing the parentheses, remember you look for like terms, and we have like terms over here on the left-hand side that should be combined. 8x minus 5x is 3x. And we also can combine these regular numbers. Positive 32 minus 5 is positive 27. All right, so let's move our regular constant term here of 27 by subtracting 27 from each side. That gives us negative 55. And then the last step, remember we don't want 3x, we want 1x, so we would divide both sides by positive 3. Now, since I divided both sides by a positive number, I will not reverse my inequality symbol. So negative 55 thirds. And we won't graph that one. But interval notation, it says x is greater than negative 55 thirds. So if it's greater than, that means you're starting at negative 55 thirds. And you're going greater than to positive infinity. And I used a bracket because I had the or equal to bar. Okay, hope you found that to be helpful. Thank you.